Good afternoon, and welcome to the value of using 3D laser scanning and 4D models. I wasn't expecting such a introduction, so I kind of had that set up within my agenda. But as you kind of heard, I am American, so please don't hold it against me. I have been here for almost 3/4 of my career, so I kind of understand what kind of the industry within Saskatchewan. We'll do a quick background about PCL. As you heard, we are originally from Saskatchewan. And then we'll go into a little bit of background of why it's beneficial to be using BIM on projects. And then we'll get into the meat and potatoes and talk about the 3D laser scanning and 4D model. So founded in Saskatchewan in 1906, PCL is a group of independent construction companies that carry out work across the United States, Canada, the Caribbean, and Australia. These diverse operations in civil infrastructure, heavy industrial, and building markets are supported by strategic presence in 31 major centers. Together, these companies have an annual construction volume of more than $6 billion, making PCL one of the largest contracting organizations within North America. A little note that we just heard about, PCL recently won a General Contract Award and Best in BIM Award for the Rocky Ridge Recreation Facility in Alberta at the 2017 CAM BIM Awards. BIM, or virtual construction you may hear it as, gives the power of foresight by allowing projects team to visualize, communicate, simulate, plan, and communicate before you even get onto a job site. Using technology like 3D laser scan and 4D models provide valuable information throughout all phases of construction. This technology benefits the client, contractor, designer, trades, and suppliers by communicating complex ideas to provide a visual understanding of project sequences and phasing, along with the schedule elements critical to project execution and completion. In addition, the resulting as-built documentation can be referenced before and after the project is completed. 3D and 4D BIM provides a clear understanding of what project will look upon completion and can serve as a visual touch point for all stakeholders throughout the entire process. It is important to know why BIM is being used on projects. It isn't just pretty pictures. You're actually communicating, collaborating, and sharing information more effectively. Also, you can possibly reduce any untimely or costly coordination from the job site, as well as any unforeseen conditions that wouldn't have been noticed from the contract documents, which gives us more time planning and less time fighting fires, and the ability to have real-time sharing of information. And this is where 3D laser scanning and 4D models come in handy. For those of you wondering what 3D laser scanning is, the Wikipedia definition is a device that analyzes real-world objects or environment to collect data on its shape and possibly its appearance. The collected data can then be used to construct digital three-dimensional models. With a 3D laser scanner, we are able to create as-built information on the existing site or building for any project. It gives us the understanding what conflicts that we may come across during construction. Some of these conflicts could be to verify ceiling space coordination, verifying the structural components are installed at the correct elevation, or even plumbing stubs that are in the right location on site per the contract documents. We can even double check how level slabs are within an existing space, or compare the detailed excavation cut to the civil design. And we are able to scan an elevation of a building to verify what the slab variance is between each floor to help the exterior contractors understand what they have to work with before stepping on site. Though using 3D laser scans as an as-built document, it's not the only use that it can be used for on a construction project. It can help give us the ability to understand what design will look like on an existing space by overlaying a 3D model into the point cloud model or the 3D laser scan. Just a quick thing, I don't know if everyone knows what a point cloud model is. It's a set of data points come in in some coordinate system. In a 3D coordinate system, these data points usually defined as XY coordinates and often are intended to represent the external surface of an object. The next few slides are examples of projects where PCL Regina has used this laser scanner. This image is showing all the disciplines that are within a ceiling space for the project. The scan has done to help us understand which of those disciplines were below the minimal height clearance that was specified in the contract documents. To understand what you're seeing in this image, the minimal height clearance for this space is represented in dark green on the legend key on the right-hand side. So any of the colors that fall below that dark green, excluding the structural components, means that the disciplines need to be rerouted to make them compliant with the contract documents. And as you can see, there are two locations where they are below that height clearance. One right here, and then another one right here. This clearly identifies to the project team and the specific trade what areas need to be corrected prior to turning over the space. To understand what the proposed routing within the ceiling space would look like for an existing structure, the design model can be overlaid with the image that was created from the scan. This helps us see where potential conflicts would be located, allowing the project team to correct those issues before trades arrive on site. In this image, everything in white is representing what was produced in the in the designer's design model, and then the colored image is what came up from the scan. When taking over a space for a tenant fit-up project, we wanted to ensure that all plumbing stubs were in the correct location per the drawings. With the point cloud model from the scan and the ability to overlay the AutoCAD file, we were able to verify any locations where the stubs weren't in the correct location, either inside the wall cavity or not. As you can see, where the 2D line CAD file is overlaid on the point cloud model, and then we are able to then recognize those spots where the plumbing stubs need to be located, and with the information from the 3D scan, we were able to determine if those spots were in the right location or not, and then if there was any of those issues, we could correct those before we took over the space. With renovations on an existing space that has multiple additions over the years, a laser scan was done to understand how level the existing slab was. As you can see from the image, the slab varied throughout the building. This helped the team understand where the slab needed to be either grinded down or filled in to fix the levelness before the new floor was installed. The brownish green color was determined to represent 0 within the project elevation. Any colors that were lighter were below that reference plane, while the colors that were in blue were higher than that plane. Just to give you a kind of an idea of what we're really seeing, it may look like there's quite a bit of variance between it, but each color change is only 15 mils. So it's pretty minimal if you look at it across the board. And then as you can see, there are a couple areas where they're red and yellow and in the image, and this shows where the new plumbing line is being installed per the new drawings. With 2 different contractors doing the civil work on the project, the laser scan was used to help identify when the contractor completed their scope of work. It was then referenced to the construction documents to ensure that it was cut to the correct elevation. The teal coloring in the image represents the elevation cut within the parking lot area that was called out on the contract documents. The browns and orange show what the laser scan picked up for the as-built elevations. It may be kind of deceived because of this location up here, but that area they already started approaching the next phase where they're putting the base layer underneath the asphalt. To understand what the variance is between the edge of slab on each floor, the exterior facade was scanned once the existing exterior walls were removed. With the information that was obtained from the scan, the project team is able to determine whether the framing of the new exterior wall needed to be bumped out or in between each floor before the exterior contractor was on site. The colors in the image represents how much the existing exterior structure steps in and out, similar to the process that was used for the floor levelness. In this example, the bright green represents the reference plane for the wall, or our base point, which is 0. Colors that were lighter, the greens, yellows, and reds, are further back from that reference plane, while the blues and purples show what's in front of that reference plane. With the ability to scan existing site conditions, project team can verify whether the structural steel is installed correctly per the shop drawings. At the same time, the team can visualize what the space will look like once the structural components are installed. The image we're seeing here is what was pulled from the laser scan, and then from there we overlaid the shop model from our subtrade. And as you can see, we now have reference of what the stair core is going to look like within the space, and at the same time, we can verify that some of the structural steel was installed in the right location. Laser scanning isn't a new technology, but something that we don't see often within Saskatchewan yet. These examples were ways that the PCL Regina District has utilized the 3D laser scanner. BIM is the intelligent linking of individual 3D components or assembly that can be found in the model or models with time or schedule related information. The creation of 4D BIM enables the various participants of a construction project to visualize the progress of the construction activities that are associated with the schedule. With the 4D model, it has the ability to continually be updated throughout the project as construction progresses or when schedule changes. The 4D model doesn't just give us a visualization of the construction for the project, it also enhances our site logistics and sequencing communication. With it being a live document, it can have filters put together during the project to help graphic communication of the schedule to the owner, architect, contractor, the project team, and the subcontractors. This gives us the opportunity to show weekly progress or even put together a 3-week look-ahead schedule for project team meetings. There are a couple different outputs that we can produce once we have the 3D model linked to the schedule. Take individual screenshots showing what will take place during that duration, and 2, create an actual video file walking you through the entire schedule. The next few slides will show you what would be used when the project team wanted a 3-week look-ahead schedule at a meeting with either the owner or the subcontractor. This comes in handy when sequencing work for areas that has multiple subcontractors in a specific area. So as you can see, as we're going through these 3 slides, it kind of references what that work is going to be for the next 3 weeks. This video is the SaskTel project that PCL is currently working on in downtown Regina. The image on the left is looking at the building's north and west elevations, while the building on the right, we're looking at the south and east elevations. The legend key on the lower left-hand corner indicates the different colors that the activities you'll be seeing during the video. The lower hand on the lower right-hand corner shows the schedule of the activities. The top band represents the timeline, and you can see it moving as the construction activity progresses. There we go. Good. Perfect. Just to give you a little understanding of what you're seeing, the appearance key on the left kind of represents, green means we're installing new items or constructing something new. The orange orange represents what's being removed or demoed. The yellow shows what's being maintained. Some items that may be maintained be like resurfacing the roof or painting a wall that's already been drywalled or even installing tiling. This was an occupied space, and because of that, we kind of had to break it into a couple phases. We started with the north face and then went around to the west face once the majority of the work was demolished on the north face, and we started to install the new exterior wall. Because it was an occupied space, we did have to break down the west face into two phases to allow the washrooms that were in that area to still be able to be used by those tenants. Once we finished the majority of the work on the west face, we then went to the south and then worked our way over to the east. And as you see, we're still working on that second phase of the west face as we are finishing up the east face. And then once we are done, that was the end of the project. So now that you see some benefits of not only BIM, what BIM can bring to your job site, but specifically 3D laser scanning and 4D models, you must ask yourself, what can BIM do for your next project?